Welcome back everyone. In this video we will actually connect our SLC504 CPU to our PC and start programming it. So we will need to start opening our needed software. That would be RSLinx. Okay. Alright. And we also need to open our device manager to know the COM number of the COM port for our PLC. Right now it's not connected. Once I connect the USB cable in my PC, the other end is actually the RS232 connected to the PLC itself, and this end would be the USB or a DB9 cable connected to your laptop. In this case I'm using a USB cable as I've shown you guys in the previous video. So now I'm connecting the USB cable and we can see that the computer is detecting the COM port. It's a prolific USB serial COM port COM3. Wonderful. We don't need this anymore. In RSLinx we will add the driver, configure drivers. You can also use this icon right here to configure your driver. We will add RS232, add new. I'll call the driver SLC504 driver. Okay, and select COM3. We don't need to adjust any of that. We'll just use auto configuration. You have to see successfully configured. Yep, auto configuration successful before you move on to the next step. Wonderful. Now that we have our driver running, okay, you have to make sure it's running. If it's not running, you have to start manually. Of course, you can configure it configure to start up manually or automatic. In this case, I'm leaving it to start automatic here. And wonderful. I'll just close this one. Detected devices. Okay, now it's detecting the PLC. As you can tell here, it detected that there is station diagnostics, just to make sure everything's fine. Active diagnostic counter rates 314. So it's receiving packets and sending messages as well. So everything is fine so far. Let's close this one. What other options do we have? Configure, DDE, OPC topic, data monitor. Okay, looks great. Station diagnostics, we've done that. Okay, station diagnostics. Okay, that's what we did. Oops, I have to open RSLinx again. We closed it by accident. Let's open also Rsloix500. Like I said, Rsloix500 needs a license. I have an issue with my license right now. I need to uninstall it and reinstall it using the original license I have. But right now I'm in a grace period and I still have 6 days, 22 hours. The issue just started 2 hours ago, which is confusing, but yeah. Anyway. Okay, RSLinx. We have the driver up and running. And we have the PLC detected. In Rsloix we will just create a new project. Choose our PLC. The number of the PLC is actually typed on the door here. It's I747L542. It's not really written if it's L542 A, B, or C model. However, I think it's a C model. Let me see. It's L542 C model. The only difference is actually the OS is different and the memory area is different as well. I believe it would be 24. You can find the exact model on the side of the PLC, but I don't want to disconnect it now since it's connected to power. I don't want to interrupt our connection to the PLC. So I will just go ahead and choose L542A, as I believe it would be compatible with the newer software, with the newer operating systems. Okay, so let's choose this one. Choose your driver, SLC5 04 driver. I will name it SLC5/04. Perfect, looks good so far. To make sure it's actually connected, I will open the I/O configuration, and like I said, I only need these two modules right here, the DC ones, the transistor logic, the transistor digital input and transistor digital output modules. The exact number, the exact model of the module is written down here. This one is 1746 IB16, and this one is 1746 OV16, and I have many other relay modules here. They don't need at the moment. I will disconnect them later. And we also have a device net module and slot number 1. So that's slot number 0, has the original PLC, and that's power supply. And then we have device net module, digital input module, digital output module, nothing, and then we have 6 relay modules. So once we read input out configurations, our driver is selected, everything looks good so far. Our PLC is selected, read input out configurations, should be able to read it. Okay, let's see. Yep, it has detected all connected modules. Okay, again the annoying activation message. Okay, so we have slot 0, we have the PLC itself. It's 24K memory, just like I selected. I don't know actually if it's the right model or that's just because I selected this model. We also have the device net scanner module. That's the exact model or part number for the module. That's a part number for the digital modules, input module, output module. I only need these two, so I don't really need all these, so I will just remove them, as I don't really like to leave unneeded hardware connected to the PLC. I'd rather having it like away from the PLC, and at the same time I don't want to disconnect them from the PLC, just to avoid leaving it open for dust and any dangerous material. Alright, wonderful. So now that we're connected, I'll just go ahead and close that. And okay, I'm just gonna upload a blank program. Unfortunately, there's no input or output connected to the PLC itself directly, and I haven't connected I haven't powered up the needed modules yet. So as you can see here, we have power output common and power output 24 volt DC. So these two terminals or two pins out here should be, we should get a wire out of there connected to a bus terminal or a terminal block, and then we start taking the needed power from there to feed our modules. One should be connected, that's the RDC input module. So the common should be connected down there, the DC common, and another DC common here. Okay, since this one is syncing module, the power would be connected to the sensor, and then it would the sensor would be a sourcing. It would be feeding this syncing module, and that's why we have the common negative here. The common should be negative as well, and the output module, but we also have the voltage, the VD, the positive voltage DC here, and the negative terminal here. So once we power up these modules, they will be powered, but of course right now, because they are connected to the PLC and using the slot in the rear of the rack itself, it was detected in our Rsloix500 software. Alright, let's see. Okay, I will actually either leave it blank. Let's just try small. This one output, and this one, let's say it's B3 0/0. Alright, okay. And this one, let's say it would be output. Okay, in this case, output should be output slot 3. Okay, let's compile. Errors, wrong to error, unconfigured input address. Oh, it should be output slot 3. Okay. Right. Then we're good. The error disappeared. We're fine. Let's download it to our PLC. File name, let's call it test. Okay, replace this one. Test RSC. It's in my documents. Okay. Processor name. Database. Save database as external files. Alright, wonderful. Yes, replace it. Okay, downloading the program from 24. Actually, our PLC should be 42C, so we have a larger memory. That's a good thing. I will update later, and I will show you guys how to update the information for the processor right now. Are you sure you want to proceed with download? Now, let me just update the controller properties. I will choose the one that was indicated right now. It's this one, 1747 L542C. Apply, resize data tables. I wouldn't clear inputs at the outputs because it's still the same slots, so we're good. Okay, let's make sure inputs and outputs are still there. Yep, they're still there. And then we can verify, no errors, verify file, and download. Okay. 42C to 40C, yes, that's exactly what we're going to do. And SLC driver, perfect, yep, download. And you can see here's RS232 LED indicator is actually flashing rapidly because we are writing our input-output information at the moment. And you can see the screen and the LED information. Wonderful. And we have successfully connected our PLC to our PC, and we have developed our great huge ladder logic, which is just one rung, and we're uploading it as well. And I will see you guys later on to discuss how to write the finite state machine for your needed programs, and then we can just develop our ladder logic or our logic in general. I actually prefer to use structured text as it's more sophisticated and can be engineered in a better way. Okay, do you want to go online? Well, we can go online, sure, why not? Okay, now that we're online, you can see this icon right here rotating, that means we're online. And you can see the RS232 is flashing rapidly because it's syncing data from my PC to the PLC and vice versa, as it's full duplex communication. And let's go down here to see our data files. Okay, I will select our output data files. You can see your data files here. Okay, great. And our inputs, these are our inputs. Unfortunately, we can of course enforce a change, like for example by writing 1 at the input. You can see it will be 1. You can write 1 at any specific output you want. 1. However, since our inputs and output modules are not actually connected, it's not really gonna do anything since we haven't powered the modules yet, as have been discussed earlier. Anyway, then we have our data files for status. Okay, daytime 1916. Wow. Let's say 2022. Month, January. Date. Today is 29th of January. Wonderful. Okay, and register processor. Scan time. Maximum 20 seconds. 20 more seconds. Status bits. I/O slot enables. Okay. Errors. STI. DA. Lots of features. Wonderful. Just remember that this PLC is an old one. It's rack based, model, it doesn't give you the full flexibility that we have nowadays in the modern PLCs that use tag-based mechanisms for assigning or for flexibly assigning the memory area as you like. Gives you great flexibility when implementing your programs. Okay, so that's it guys for connecting the PLC, and I'll see you later to actually develop our program. Thank you.